much more. Here, we get the space to explore all our passions.
College teaches you to see beyond your capabilities, to visualize the unthinkable and catch the unachievable. Life gives you certain opportunities to build your life, but college gives you the platform to live your life. Here, we share our memories, our stories, and our happiness. And it's a roller coaster of emotions. And before you know it, you'll realize that they have turned from friends into family. It isn't always about books, labs, and assignments. Academics are important, but there's definitely more to education than that. It's about finding yourself, about who you really are. It's about carving your own path. In this process of learning and growing, you build your own future. And then by the time it's all over, you realize that you're yet to explore so much more. What seems like the end is just a beginning. Come, find your beginning with us.
Avani,
Good evening, ladies and gentlemen. I'm Avani Shahj.
And I am Shruti Venugopal.
We are scholars of St. Joseph College of Engineering and Technology, PALAI, and we will be hosts throughout the session. Welcome to the fourth day of the AICTE Training and Learning ATAL Academy Online Faculty Development Program on Next Gen AI Innovations in Machine Learning, Deep Learning, and Generative Models. This prestigious event is organized by the Artificial Intelligence and Data Science Department of the St. Joseph College of Engineering and Technology, PALAI Autonomous. In this section, the seventh session focuses on an overview of natural language processing, and in the eighth session, it will be of the customer review analysis using machine learning and NLP techniques.
Before we start, I would like to introduce the chair for this session, Ms. Jebin Matthew and Ms. Sarita MS, Assistant Professors in the Department of Artificial Intelligence and Data Science at St. Joseph's College of Engineering and Technology, PALAI. They are very dedicated teachers and strong supporters of our innovation and learning in the field of AI and data science. They will guide us throughout this session. We welcome both of you to this session.
I'm excited to introduce our esteemed speaker, Dr. Shailesh Shivan, a visionary academician, a prolific researcher, and a skilled educator who has made remarkable contributions to the fields of artificial intelligence and data science. Dr. Shailesh Shivan is currently an assistant professor in the Department of Computer Science at Cochin University of Science and Technology, Kochi, Kerala. With over 12 years of experience in both academia and industry, he brings a unique blend of theoretical knowledge and practical expertise. His core areas of interest include machine learning and deep learning, natural language processing and data mining, computer vision and knowledge graphs, quantum computing and soft computing.
He holds a PhD in computer science from CUSAT, where his thesis focused on spatio-temporal pattern recognition in dance using machine learning techniques. Before joining academia, Dr. Shailesh Shivan held key roles in the industry, including as a senior software engineer. He worked at Travancore Analytics and Tech Gencia Software Technologies, developing C++ applications, video conferencing tools, and other innovative solutions. He also served as deep learning consultant, offering AI and machine learning solutions for retail, banking, and software engineering projects.
He has made significant contributions to the research community. He has published numerous SCIE and Scopus Index papers in prestigious journals and conferences, focusing on topics like spatio-temporal pattern recognition, deep learning, and NLP. He has received several accolades, including the Young Scientist or Researcher Award in 2020, where he was recognized for his outstanding contributions at the institutional level. He has also achieved the President Scout Award or the Rashtrapati Scout Award, where he was honored for his leadership and dedication at the national level. He has also qualified UGC NET, JRF, and GATE multiple times, reflecting his academic excellence.
He is also an engaging speaker and a skilled trainer. He has conducted numerous workshops on AI, machine learning, big data, and Python programming, empowering students, researchers, and professionals to embrace the transformative power of these technologies. His technical arsenal includes tools like TensorFlow, PyTorch, Keras, and advanced Hadoop clusters. He is proficient in a wide range of programming languages such as Python, R, C++, and Java, and adept at big data processing frameworks like Spark and Kafka. This evening, Dr. Shailesh Shivan will lead us through two thought-provoking sessions. First session will be on overview of natural language processing, a foundational area in AI that allows machines to interpret, process, and generate human language. And the next session will be on customer review analysis using machine learning and NLP techniques, which is a practical dive into how businesses can leverage AI for actionable insights from customer feedback. We are indeed fortunate to have someone of his caliber to guide us through this fascinating topic. Ladies and gentlemen, please join me in welcoming Dr. Shailesh Shivan. Over to you, sir.
Hello, am I audible now?
Yes, sir.
Okay. So thank you, St. Joseph's College of Engineering and Technology, PALA, for inviting me as a resource person for this prestigious workshop for nurturing the young faculties in our country. And thank you, the host, for giving such a wonderful introduction regarding my profile. So, can we start directly, or do we need to wait some more time to join more participants?
Sir, we can start. Some of them will join through in this session later. No
Okay, fine.
problem. They will join us.
Okay, fine. So let me share my screen first. Okay. So how will be the schedule first? The first session is from 6 to 7:30, right?
Yeah, 6 to 7:30.
Then we will be having 10 minutes break.
Yeah, we can take the 10 minutes break, and then after that, customer review analysis using machine learning. And
Yeah, okay, fine. Yeah. Is the screen visible to you?
yes, sir.
Yeah. So before starting with natural language processing, hope you are all had the introduction to AI, machine learning, deep learning, and all, right? So we can have a brush up on that, or we can make it as an interactive session before starting with NLP. So can someone tell me what is the intention of artificial intelligence? Dear participants, be active in the session, be interactive. Otherwise, the session will be very boring to you. Okay. As I'm not seeing your face, I cannot get your response or what you feel and all. So to make it more for interesting, I request all the participants to be very interactive throughout the sessions. Okay. So we can start with artificial intelligence. Okay. So can someone give me an idea of what is artificial intelligence or what is the intention of artificial intelligence? Any participant?
To mimic human behavior.
to mimic human behavior. Any other opinions? Am I am I properly audible now? Is there any disturbance from my side? Yeah. Okay. So, uh, for the time being, I just want to show you one more slide. Okay. So, yeah. So the mimic human intelligence. Any other definitions for artificial intelligence?
To train machines.
To train machines. Okay. To think like a human, right?
To automate
Yes,
tasks.
sir. So to make machine intelligent
To make a machine intelligent. Okay.
so that it can behave like human being,
It
think
can
like
behave.
human being.
Okay, fine. So from this figure, you can see that there are several buzzwords currently we are experiencing in our day-to-day life, right? Artificial intelligence, data science, big data and all. And the one of the dominant area itself is artificial intelligence. And the intention of artificial intelligence is to make a machine think like a human, right? And technically, we are speaking, what is artificial intelligence? It is actually a branch in computer science. Okay, it's a branch in computer science that intends to make, or that is trying to induce some kind of intelligence to a computing system with the help of data and a set of sophisticated algorithms. Okay, fine. So with the help of that points need to be keep in mind, with the help of data and a set of sophisticated algorithms. Okay. So when it comes to artificial intelligence, the intelligence making strategy, how we are actually making intelligence. If I ask you, are you people intelligent? What will be your response? Are you people intelligent? Yes, definitely we are all intelligent, right? But think about the intelligence making process happened in us. See, are we making this intelligence in the same manner, or are we depending on the same source to make intelligence? We can make intelligence through observation. We can make intelligence through practice, right? We can make intelligence through learning. We can make intelligence through listening, right? There are different aspects where we can focus on for making intelligence, right? Okay. So, likewise, in artificial intelligence, also, we have different subdomains that explains different way of making intelligence to a system, right? Okay. And within that, the predominant subdomain is machine learning, which relies upon a technique called learn from experience, which relies upon a strategy called learn from experience. Okay, fine. Apart from this machine learning, we can make intelligence to a system with the help of speech analysis and processing, computer vision, natural language processing, expert systems, planning and optimization, and robotics. All these subdomains are actually depending on different modalities of data as well as different strategies to make a system intelligent, right? So, can someone tell me a very critical question? That is, can can you tell me one artificial intelligence technique or a artificial intelligence use case which is not a machine learning task? Anyone? It should be. an artificial intelligence technique or a use case, but it should not be a machine learning task. Any idea? Someone in the from the participants? You can guess actually. I'm not asking for the correct answers. I'm just asking about your thoughts. An
Sir,
artificial
chatbot.
intelligence
Chatbots.
Chatbots, sir.
chatbots. Yeah, chatbots. So the point I just want to convey is, apart from machine learning, there are a lot of techniques included in artificial intelligence. But when we talk about artificial intelligence, most of the time we are specifying the intelligence making process as a learning technique, right? But keep in mind there are a lot of other techniques within artificial intelligence which is not necessarily the machine learning. But the scenario now we are going through is, we can see the domination of this machine learning very widely in all other domains in artificial intelligence. Okay. So whenever we are looking into different implementations of artificial intelligence or different robust and efficient models of artificial intelligence, whether it is speech or vision or natural language processing or whatever it is, we can see the predominant influence of machine learning in all these use cases, right? So nowadays we can say that this this domain of artificial intelligence is actually taken up by the machine learning, or somewhat machine learning is now equivalent to artificial intelligence, right? So definitely when we are learning about speech systems or computer vision systems or natural language processing expert systems and all, everywhere we can actually uh, look into, or everywhere we can actually we see or experience the applications of machine learning in it. Okay, so definitely in natural language processing too, we must be understanding that there is a big part of natural language processing is taken up by the machine learning and deep learning domain. So even though it is actually taken up by this huge techniques involved with this deep learning, like the transformers, GPT, BERT, and all. The understanding of basic aspects of natural language processing is very important to to tune the models, or as well as to work in a very deeper manner with this models. Okay. So that is why we are focusing on the natural language processing basics at the beginning of this session. Okay. So how will you relate this machine learning and deep learning? What is your idea? How the machine learning is connected to deep learning?
We have a very huge amount of data set. Then we go for the deep learning. If we have limited data set, then we can choose ML as per my knowledge.
Okay. Is there any other relationships, like what made deep learning so much powerful?
Automated learning.
Automated?
Automated learning.
Automated learning, that is automated feature learning, right? So
Yes.
in a traditional machine learning pipeline, you can see that, see, what we are actually doing is the problem we are trying to solve with machine learning need to be understood by the machine learning engineer, right? Then according to the domain knowledge or the problem's peculiarity, from the raw data, machine learning engineer need to identify and extract the relevant features which is useful for the next stages of the machine learning pipeline. And these features need to be extracted in a proper way, and it can, so that it can be fed into the machine learning algorithms like classification of regression like that. And ultimately, we can say that the performance of a machine learning model is directly depending upon the clarity of the features you have defined, identified, and extracted from the raw data, right? But when it comes to deep learning, what happened is, see, the part of feature engineering is actually taken up by the neural network itself, the deep neural networks itself. Okay, so there is a big advantage of automatic feature learning in the case of deep neural networks, right? Hope it is clear, right? These points are clear to you, right? Okay, now we can move into natural language processing. Okay, so natural language processing is actually a branch, a sub branch in artificial intelligence, and we can say it is actually evolved from a traditional subject which is called as computational linguistics. Okay, computational linguistics. Then, what is actually natural language processing? So it is a branch of artificial intelligence that gives machines the ability to understand human natural language. Okay, a human natural language. At the same time, there is another aspect. It helps us to generate something meaningful to the humans. Okay, so in when you look into the hierarchy of natural language processing, you can see two major tasks we are doing. That is NLU and NLG. Okay, NLU and NLG. The one is actually called as natural language understanding, and the other one is natural language generation. So together, natural language understanding plus natural language generation, we can say the domain of NLP is actually defined. Okay. So the billions of text being generated every day, and most of them are unstructured. And from this textual data, we have to find some kind of insight, right? And or you need to interpret that huge amount of data with the help of computational techniques. Okay, that computational techniques involved in understanding and generating natural language is actually called as natural language processing. Okay, so you may be getting confused like is NLP, computational linguistics, the text mining, everything is same, right? If you look into those domains, we can see a big intersection between this natural language processing or this computational linguistics or this text mining and all, big intersection between these things. But apart from those intersection, there are some isolated tasks involved in each of them to make it different from each other. Okay. So in natural language processing, as I said, it is a branch of artificial intelligence that gives machines the ability to understand and generate natural human language. Okay, hope it is clear, right? Then, if you look into different applications of natural language processing, we can see the machine translation is one application, then information extraction is one application, sentiment analysis is one application, information retrieval is one situation where we apply NLP, and question answering system. These are all the major uh, applications of natural language processing. Okay. Now, when you look into the tools which are widely used for natural language processing, we have NLTK, that is Natural Language Toolkit, which is supported by Python. A Spacey is another library. A text blob is another library. Gemini is an Gensim is another library. Okay. And with this, all these libraries, we can actually enable or we can actually implement traditional natural language processing tools. Okay. Can you tell me some of the new gen natural language processing tools? Any three? Any three new applications that uses or that includes natural language processing? The popular applications. No answer.
Sir, chatbot uses.
Chatbots are there, but I'm just asking about the new one of the new application, one of the new software tool you can see see over internet.
You are talking about ChatGPT.
Yeah, exactly. ChatGPT is one such natural language processing tool, okay, which transform the human perspective towards this artificial intelligence, right? So such kind of applications can be enabled or realized with the help of these tools. Okay. Now, what are the common terminologies in natural language processing? These are the very relevant techniques we always used in the natural language processing pipeline. Okay. So the sentence segmentation, word tokenization, stemming, lemmatization, stop word analysis, dependency parsing, part of speech tagging, and all. Right. Now, we can discuss each of them in detail, and also we can have the hands-on session after this on each of this stages. Okay. So, what is sender segmentation? What is the input for a NLP process or NLP application? Definitely a text, right? So, what is a text? What do you mean by a text? What do you mean by text? Anyone can answer. What do you mean by text? Textual data.
Part of sentence.
Written words.
Sir,
Written word.
sentence segmentation is the
No,
dividing the
I'm
sentence
just
into
asking about text. What is text?
A
Not about
uh,
combination
sentence.
of
collection of alphabet.
Exactly. A collection
A
of
set of
or a
alphabets.
sequence of alphabets or
Details.
tokens can be considered as a text, and may or may have some context. If it is it is possessing some kind of meaningful context, we can say that can be as a text data, right? Now, the first stage in every machine learning or any NLP pipeline which uses text as an input is the sentence segmentation. That is, divide the entire paragraph into different sentences for better understanding, right? Suppose you have a textual data, the textual data need to be splitted into several sentences. Okay, divides the entire paragraph into several sentences for better understanding. So you can see the example here. The input to the sentence segmentation is hello world. This blog post is about sentence segmentation. It is not always easy to determine the end of a sentence. One difficulty of segmentation is periods that do not mark the end of the sentence. And there are a lot of sentences involved in that paragraph. And after doing the sentence segmentation, see, you can get hello world as one sentence. This blog post is about sentence segmentation. Likewise, with the delimiter that represents the end of a sentence, we can split the entire text into different sentences. Is it clear? What is sentence segmentation? Is it clear?
Yes, sir.
Yeah.
Yes, sir.
Yeah. Now we are moving into the second thing, that is tokenization. Tokenization is nothing but if we are doing that segmentation in a word level, okay, that is breaks the sentence into separate words or block or tokens to understand the context of the text. Okay, that is what we are calling as tokenization. So if the input is we love NLP, after the tokenization we have we allow NLP and exclamation as different inputs. Okay, it will be converted into different, a single sentence will be converted into different tokens or words. That is what we are calling as tokenization, right? Now, stemming and lemmatization. So, what is stemming and what is lemmatization? Both the things seems very similar and like apart from the algorithmic part of this implementation, they seems like very similar. Okay, like stemming is the process of cutting off prefixes and suffixes to reduce a word to its root form called the stem, and it may not be a valid word in the language. Okay, and lemmatization reduce words to their base or dictionary form known as the lemmas. So, as a part of stemming, you are getting the output as a stem, and as a part of lemmatization, you are getting the output as a lemma. Okay, see here the word change, changing, changes, change, changer is mapped to chung, right? And for the next case, see the output we got from change, changing, changes, change, and changer is change itself, right? The root word in the dictionary itself is obtained as an output. Okay, okay, is it clear? Stemming,
Yes, sir, clear.
yes.
Yes, sir.
So what you can observe from stemming and lemmatization? Which technique is more intelligent?
Lemma,
Yeah,
lemmatization.
lemmatization is more intelligent because when you try to stem some words which is the present in our natural language, after the stemming that word become very unmeaningful, right? But in the case of lemmatization, they will keep the context and meaning and getting the result, right? So more accurately, you can do lemmatization than modernization. See? Lemmatization rather than stemming. Okay. Now we are moving into the next technique, which is called as stop words. Okay, stop words. So stop words are a collection of words which are present in any language uh, where that words will not convey any kind of useful information, or it is having a less very useful information, or it will not be giving any kind of context to the entire input sentence. Okay, so in English there are a lot of stop words like a, off, on, I, for, with. These are all what stop words which is not giving any kind of context or meaning to the actual input text data. right? So stop words need to be removed from the input data so that we can get more clarity on our input. Okay. Then part of speech tagging, otherwise it is called as POS tagging, is nothing but if we are giving a particular sentence, okay, if you're giving a particular sentence, the each of the tokens within that sentence will get mapped into a particular part of speech. The part of speech is nothing but, see, for English grammar, we have noun, pronoun, verb, adverb, adjective, preposition, conjunction, and interjunction, right? Likewise, in natural language processing too, if we have an input, we will be mapping that input to a particular POS tag. Okay, and there are so many algorithms exist for this, and by make use of this algorithm, we can implement that part of speech tagging in a very easy manner. Okay, very easy manner. And the other one is named entity recognition. Okay, named entity recognition. So in the case of named entity recognition, what they are doing is, see, suppose you are giving a sentence. Okay, suppose you are giving a sentence, and from that sentence, you need to find what all words are actually representing the organization, what all words are uh, surprisingly be a name of a person, or what all words or tokens can be a date, a cardinal, like this. Each and every tokens which are contributing towards the context will get mapped into a particular kind of uh, entity tags. Okay, fine. So that is what we are calling as named entity recognition. Okay, hope this is clear for you, right? So this part is actually taking the very basic pre-processing steps or the processing steps in the natural language processing. After this, we are actually going to move to how this text can be properly explored for different uh, machine learning or advanced analytic tasks. Okay, so is it clear so far?
Yes, sir.
Yeah. Is there any confusions regarding the topics? Okay. So are you doing the practicals along with me, or should I need to just demo? What is it?
Show the demo, sir.
Yeah, it's enough, right? So is my screen visible now for you? Is my screen visible to you?
Yes, sir.
The codes, are you able to see the codes in Google Colab?
Can you zoom it more?
Yeah, sure. Okay, right. So the first purpose is to import the Python package. It's called as NLTK with a particular version. Okay. So we are importing that, we are installing that NLTK in Google Colab. It will take some time. So NLTK is now installed. Okay. So the next task is to import NLTK. Okay, import NLTK. For that, we are giving the statement import NLTK. Okay, is that clear? Now we have to download several models which is available in NLTK for a specific language, right? So for that, NLTK dot download of Punkt, Punkt. Okay. So on executing, you can see that that particular thing is downloaded. Okay, particular thing is downloaded. Okay. So this lemmatization, like or some features within natural language processing, the Punkt package subpackage will help you to get the proper results. Okay, so we have the tokenization, the lemmatization, the sentence tokenization. Everything is actually uh, included in the Punkt package. Okay. So the next part is tokenization that we have discussed. Okay. So see the example string. This is a sentence with him learned rapidly because his first training was in how to learn. Okay. And the first lesson of all was the basic trust that he could learn. It's shocking to find the how many people. Yeah, so there are a lot of sentences. Okay. So our task is to do the sentence tokenization first. For that, we are loading a particular functionality send tokenize from the NLTK tokenize. So from NLTK tokenize import send tokenize. Okay, import send tokenize. And also here sentences. Okay, so this sentence tokenize function will again take the as a input as a string, and it will split out all the sentences as a list of list. So you can observe the output of the sentence tokenization here. What you can observe? Can someone tell me what you can observe from this? What happened to our words? Can you tell me what will be the output from sentence tokenization?
It
Is it
splits the
separating the
entire
sentence?
paragraph into two separate strings as a list.
It's not two. Actually, each of the sentences delimited with a full stop will
Okay.
get splitted into several sentences, and these several sentences will be returned as a single list. Oh, is that fine? Yeah. So after getting this sentences, okay, if you want to go through it, you can simply use a for loop. For S in sentences, print S. Okay, so you can see the each of the sentence is actually getting printed. Okay, fine.
Yes, sir.
Yeah. So for S in sentences, print S, you will get each of the print. So after sentence tokenization, what we need to do? We need to do the word tokenization part, right? Word tokenization. So NLTK the tokenize, import word tokenize. So the example string is a set of sentences, right? A paragraph. Now, what we are doing is we are doing the a word tokenization in the variable words, print words. So you will get printed with all the words in it. Okay. And for W in words, print W. So what is happening there? The sentences is actually getting converted into a set of tokens, a set of meaningful words. Okay. And these words are again iterated. Okay. Through a for loop. Then you can see what all words are actually getting tokenized. Okay. So here you can see all the tokens in it, right? And there are words like to, his, of, kind of stuff, right? So after getting the words, okay, okay. So here data is a empty list for S in sentences. Data dot append of word tokenize of S, print S. That is, we are going through each of the tokens in the sentences and putting it as a data, the array data. Okay. So you will get a set of words after splitting each sentence into different words. Okay. And the next is the stop word filters. For stop word filter, you can make use of NLTK or download of stop words. So it will give a minimum set of downloads here. Sorry, minimum set of stop words here. And with the stop words, we have to check whether our sentences or the input text is having some kind of stop words, then we have to remove it from our data. Okay. So here the NLTK download the stop words. Okay. Now the words are again converted into the words from the English corpus, that is the stop words from the English corpus is actually loaded using stopwords.word of English, and it is actually keeping as a set. Okay, so you will get the set of all uh, stop words within the English alphabets. Okay, or English language model. Okay, so see, if you print the stop words, you can see a, about, above, after, again, against. These are all the different stop words you can have in the English language. Okay, hope it is clear for you, right? Is there any confusions so far? Any confusion so far?
No, sir.
Yeah. Now, see, we are doing the word organization and sentence organization together with an example. See, Wolf caught is equal to sir, I protest, I'm not a merryman, right? So in words caught, what we are doing is we split the data into several tokens and remove the stop words. And how you are actually removing stop words? You have to load the stop words and stop words. Okay. To remove, see, to remove the stop words from our data, there are different cases. Okay. The first one is, see, we have a sentence, we have make it into different words. Okay, so we have to get a filtered list of words for each word in the in quotes, word in quotes. Okay, then we will make it into upper cases. Okay, make it into upper cases. Okay, and sorry, make it into lower cases, then we are checking that our particular word in the sentence is present in the list of stop words. If it is present, it will be excluded. Otherwise, we will keep it that as it is. Okay. Have you got the logic here? How the stop words are getting removed? Logic in this part?
Yes, sir. Yes, sir.
Yeah. Now the stemming. So you can actually see the difference of stemming and lemmaization here. See, for the stemming, I'm just importing the Potter stemmer from nltk.stem. Okay. And the word tokenize from nltk.tokenize. Okay. So first we have to create an object. Okay. Then see what happened. Single word is equal to stem of goes. So the single word is go, G-O-E. So it is not actually a very intelligent transformation. It will remove some of the end characters, right? And see what happened here. The crew of USS Discovery discovered many discoveries. Discovering is what explore to. Okay, that is a sentence. On converting it into word tokenizers. See, you can see a lot of tokenizers. Okay, a lot of tokens here. The crew of the USS Discovery and all. Then the words are now taken into a list. How you are taking that? See, stem of word for each word in the words. That is, by taking each word, the crew of the USS Discovery, you are applying the stem function from the stemmer to each of the word, and you will be getting the words after the stemming. See, see, sometimes the meaningfulness of the word is getting losing, and the same root word is not getting preserved here. See, discovery is different, discovered is different. So according to the correctness of the transformations which is happening on the words, more than stemming, we have to focus on lemmatization. Okay, so here see, for the lemmatization I am using from nltk.stem import wordnet lemmatizer. Okay, so lemmatizer equal to wordnet dot lemmatizer, that we have created the lemmatizer object. Then we are downloading the wordnet from the cloud. Okay, fine. Then you will also download a model for the work of this wordnet. Okay, now see what is very simple, that is lemmatizer dot lemmatize of better comma pose is equal to a. Okay, so for better you will get another word good, right? Another word good. Okay, so lemmatizers dot lemmatize of calves is scarf, right? So not mere removing the last character will not give the root word. So we need to apply some kind of intelligence to it to make it more clearer. Okay. Then see the another example for lemmatizing, string for lemmatizing the friends of Destovo love scarves. Okay. So after doing the tokenization, okay, after doing the tokenization, we are applying the lemmatization on each of the word, and finally we are getting the friend of Destovo love scarf. Okay. And see lemmatizer dot lemmatize of worst. Okay, it is worst itself, but when it comes to adjective it become bad. Okay, so these are the lemmatizer and stemming techniques available in NLTK package. Okay. And the part of speech is again a very interesting area that is sometime to get some information, historical information. Then the part of speech will tag each of the words or the tokens in the sentences to a grammar word. Okay. See here, Sag and Cod. If you wish to make an apple pie from scratch, you must first invent the universe. Okay, universe. So this is the sentence we have. We are printing that. We are applying word tokenization on it. Okay. Now we are downloading the tagger. Okay, NLTK dot download tagger. So we are downloading it. Okay. Then see apply the post tag function. Apply the post tag function on the given set of words, then you will get each word will get mapped into as part of speech. Okay, part of speech. Are you getting it? Is it clear? Are you following the code part?
So by mean tag, we are treating the words as per the English grammar.
Yeah, as per the English grammar. And there are help supports for getting the meaning of each of the tag. Suppose on getting IN, we don't know what it is, right? So there is a provision here, tag sets, to get the information regarding different tags. Okay. So here the IN is a prepositional conjunction. Okay.
Yes, yes.
Yeah. So you will get,
Okay, sir.
yeah. And the last part for the basic pre-processing techniques in NLP is the, see one more example for this pure style. See, Jabberwocky Expert. We are doing the same thing. And the last part of this pre-processing techniques that is involved in uh, basic NLP is the named entity recognition. So the named entity recognition is also a good model for tagging our text to some of the objects. Okay, a named entities. We can say a named entities. Okay, so for that, NLTK dot download maxen underscore ne dot chunker. Okay, then if you're giving a particular word sentence, see particular sentence, what is happening after doing the word tokenization? We are applying the post tag. Okay, then each of this word within our texture input will get mapped into some of the labels. Okay, what is that label? A label is nothing but it. Hello, hello, hello. Is there any issue with my audio or
No,
video?
no, sir. No, sir. I think it's a noise.
Noise. Okay, fine. So we are having a sentence. We are first tokenizing it. Then the tag tokens are getting by applying post tag. Then we will get each of the sentence is actually getting mapped into a particular. Hello, is it a noise or you want to ask anything, ma'am? Okay. So each we will get the uh, words or the tokens within the input
Sir,
Input by tagging. Yeah.
are we categorizing the tokens by this with the labels?
Yeah, this is actually a standard. We can actually create our own custom INEAs too, named entity recognition. Usually in here, it will be a noun will be there. Okay, so such kind of things will be sorry. I think there's a mistake in the code. This is simply an let me load one more code. Okay. No. Silver screen is visible, right?
Yes, sir.
Yeah. So these are the things we have already discussed. Is zoom level okay? Is it visible? Visible now?
No, it's
Yes, sir, visible.
Yeah. So the part we are actually discussing is after the stop words, yeah, filtered word stemming, amortization. Okay. Yeah. So there is another package which is very useful compared to NLTK, which is called as Spacey. Okay, Spacey. So in Spacey also, see, we can import this Spacey part. Okay, and load the knowledge regarding the English corpus. Okay. Now, see, the part of speech can be done very easily with C. NLP is equal to spacey dot load the English knowledge. Then we have the input. Text is equal to quick brown force jumped over the lazy dog. Then apply this NLP object on the text. Then you will get the dog. Then on taking this tokens dot tag from the tokens in the dog, you will get the you will get the tokens in it. DT, JJ, noun, adjective, determinant, noun, and all right. Also, it will give a dependency parser. It will represent the entire thing with a dependency parser. Here we can see that the quick brown fox, that is the quick brown, the adjective, the determinant, and this adjective is referring to the noun fox. Okay, so jumped, the verb jumped is connecting the nouns fools and over. So this kind of visualization can be obtained with this Spacey package. Also, another thing is the named entity recognition, the NER. Here also see the President Barack Obama gave a speech at the White House. Okay. So NLP equal to Spacey dot Lord of English Core Web SM. So you are getting the knowledge regarding the uh, English corpus on the variable NLP. Then we are applying NLP on text, which returns dog. Okay. Then you have to take each entity from the doc. See what is happening for entity in doc.entity. We are printing the text and as well as the label for it, and it is also getting rendered or displayed with the help of display C, that is a object to visualize this. Okay, so the Obama, a person. Barack Obama is a person. The White House is a fact. Okay. So here what is happening is, see, these words will get highlighted according to the part of, according to the named entity recognition. As I said, there will be a fixed set of named entity recognition tags. You can actually get that from, see, if you look into in space C. Space C will give you the tags. See, these are the properties and these are the tags. See, the person, okay, for people including fictional, then not nationalities or religious something, FAC, FAC is a facility, building, airport, highway, bridge, etc. Okay, so usually when we apply the spacey for NER, it will map the uh, sentence into different entities. Okay. So hope these things are clear for you, right? Is it clear? Any
Yes, sir.
doubts regarding this? If it is clear, we can have a small break for 10 minutes. If you can join by 7:20, we can discuss the rest of the things that we are jumping into different text feature extraction techniques, as well as how to implement text classification models with Python. Okay. And if the time permits, we can discuss about the deep learning techniques, particularly the RNN family, RNN, LSTM, and GRU kind of stuffs to discuss on how these things are applied on this natural language processing. Okay, so coordinators are there. Can we have a break?
Yeah, we can have.
Okay.
excitement of experiencing something new, something different. Looking at these new faces, those smiles and chit-chats, I knew my life is gonna change. Learning something new ignites a fire in us. Here, we are encouraged to think out of the box and understand concepts that are taught out of the class. We can sit together, discuss with our friends, and clear our concepts. This way, we can ignite this fire more and more daily.
For a young maker like myself, labs like these helped me start my journey into the world of technology. I fell in love with what I learned, and the sheer thrill of seeing the concepts come to life is just like nothing else.
I know. The things you learn while actually involving in the process and doing things for yourself helps you understand, connect the dots, and remember so much better.
You know the feeling of making something with your own two hands? The joy and satisfaction it brings you. That is what pushes me forward to do more.
Yeah, it has given me happiness and confidence. Like I found myself, my passion for technology.
I just love colors. Every time I paint, I feel powerful. It is a form of expression for me, almost therapeutic. Here, I have always been encouraged to cultivate and harbor this artistic side of mine. And it's not just art, but music, dance, photography, and much more. Here, we get the space to explore all our passions.
College teaches you to see beyond your capabilities, to visualize the unthinkable and catch the unachievable. Life gives you certain opportunities to build your life, but college gives you the platform to live your life. Here, we share our memories, our stories, and our happiness. And it's a roller coaster of emotions. And before you know it, you'll realize that they have turned from friends into family. It isn't always about books, labs, and assignments. Academics are important, but there's definitely more to education than that. It's about finding yourself, about who you really are. It's about carving your own path. In this process of learning and growing, you build your own future. And then by the time it's all over, you realize that you're yet to explore so much more. What seems like the end is just a beginning. Come, find your beginning with us. When I first walked through the college gate, I never really knew what to expect. There was so much confusion and unfamiliarity. Yet, there was a certain sense of excitement, of experiencing something new, something different. Looking at these new faces, those smiles and chit-chats, I knew my life is gonna change. Learning something new ignites a fire in us. Here, we are encouraged to think out of the box and understand concepts that are taught out of the class. We can sit together, discuss with our friends, and clear our concepts. This way, we can ignite this fire more and more daily.
For a young maker like myself, labs like these helped me start my journey into the world of technology. I fell in love with what I learned, and the sheer thrill of seeing the concepts come to life is just like nothing else.
I know. The things you learn while actually involving in the process and doing things for yourself helps you understand, connect the dots, and remember so much better.
You know the feeling of making something with your own two hands? The joy and satisfaction it brings you. That is what pushes me forward to do more.
Yeah, it has given me happiness and confidence. Like I found myself, my passion for technology.
Hello? Hello?
I just love colors. Every time I paint, I feel powerful. It is a form of expression for me, almost therapeutic. Here, I have always been encouraged to cultivate and harbor this artistic side of mine. And it's not just art, but music, dance, photography.
Hello? Can we start? Yeah. So far, we have discussed about some of the very primitive techniques, which includes in the natural language processing, and most of these techniques are widely used in every kind of NLP application. Okay, now we are into one of the major technique, which is called as text classification. So for text classification, we have to first extract the features from the text to represent it context. And with that features, we are actually performing the classification using a machine learning algorithm. Okay. So what is actually a feature and what is particularly a text feature? So, can you tell me what is your idea about a feature in machine learning? Why features are important? Anyone can tell me your ideas? Hello?
Sir, for increasing the accuracy, need features in ML.
For increasing the accuracy, we need to use features. Is that your answer?
Yes, yes.
To recognize.
To recognize. Okay. So I will tell you some, explain it with some examples. Okay.
The core
Suppose
component of an object is known as feature.
the core
Take a
component of
decision, sir.
to make a decision. Yeah, I got several points and I will aggregate all these things together. Okay. So suppose you are thinking about a feature, it is not only depending upon the object we are trying to analyze, but also depends on the problem, the specificity of the problem is also depends on it. Okay. Like suppose if you consider a student as an object, what are the core properties? As you said, if you consider a student, what are the core properties of a student? Any idea? You can tell me in a very layman's perspective way. What are the core properties we can consider about a student?
So we need to identify uniquely that student. Then we have
Student
then we
name,
should, yeah, student roll number or name.
roll
That,
number.
yeah, that
Yeah,
we
these
can.
are the things, right? Yeah, these are
Yes,
the core properties. But when we are trying to predict whether the student will pass the exam or not, will this name or roll number matters? Will that properties contribute towards this decision?
no, so
No,
No, sir.
no. So the core properties of an object can be a feature, but it need not to be a feature. Okay. So here for this particular application, we can consider the IQ value of a student. Okay. Then how much studies he spends for, how much time he spent for studies, or even what are the average marks he obtained for the last or previous few exams. These are the things that help us to make a decision on whether the student will pass the exam or not, right? So features are attributes specific to an object which contributes towards the decision making process with a machine learning task algorithm, right? That is what we are calling as a feature. See, suppose we are trying to classify a set of apple and set of banana images. Okay, set of images of apple, set of images of banana. Can you just give an idea about what features I can extract from the images to do so?
Its color, its shape.
Yeah, its color and shape. Definitely. Yeah, that is a very perfect answer. And but if the scenario change to like if we have a set of apples and set of strawberries, what will happen? Will the color help?
size, sir, size.
Its size.
Maybe if you take the pictures in a zoom in, zoom out manner, will the size help? If we are zooming in for taking the pictures of strawberry and zooming out for taking the pictures of apple, both will appear in the same size, right?
Yes,
Yeah.
yes, sir.
Yeah, and maybe the shape will help, right? One is in a circular shape, the apple will be in a circular shape, and strawberries may be having a triangular shape, right? Maybe sometime. But again, if it comes to apple and tomato, what will happen? Apple and tomato, that become more complex, right? The features we need to identify or extracted from the input become more complex, right? Okay. So depending upon the problem and the data we have to extract relevant set of properties from each of the raw data that contributes towards the decision making process using a machine learning, right? That can be called as a feature, right? So in textual data, in the case of images, we told like shape, the color, the pattern, these things can be considered, right? The texture can be considered. But what happen if we move into the context of text? What are the features I can extract from text? Okay, so that is the part we are discussing here. See, usually if this is a sentence, okay, this is a sentence, we have to keep that sentence as a vector. A vector is nothing but it is a collection of values, okay, collection of numerical values. So, how we can transform the sentence into a vector? Okay, so the simple idea is that see the quick brown fox jumped over the brown dog. Okay. So what is the simplest idea? You can create a dictionary of all vocabulary, okay, and you can map an index to each of the word. You can give an index to each of the word, right? Then you can use that index to represent the entire text as a numerical value. Are you getting it?
Yes, sir.
Are you,
Yes.
are you getting
Yes,
my
sir.
idea? Yes. So we can assume that in the given example, the word the is mapped into the index 1. The word brown is mapped into index 13. That is why whenever brown is present, we are actually having 13 as a value, right? So this is a usual way we can convert a text as a feature, right? So mostly what we are doing is we use several techniques, particularly bag of words, term frequency, inverse document frequency metrics, that is TF-IDF metrics, as well as word embedding. Okay, word embedding. These are the traditional techniques we are always using for making vectors out of a text. And ngram is actually an auxiliary technique that helps to create a relevant set of features. Okay. Now, when it comes to ngrams, see, ngrams are the combination of multiple words used together. Okay. So if ngram is equal to 1, which is called as unigram, ngram equal to 2, it is called as bigram, ngram is equal to 3, n is equal to 3, it is trigrams, and so on. Okay. So if you are having an input, this is big data AI book, you will simply consider this text as a unigram, like this is big data AI book. But if you want to convey this particular text using bigram, then this is big data AI and AI book. This will be the bigram. And if it is diagram also, this big is the big data AI and data AI book, right? So we are taking the words coming together as a sequence. Okay, hope you got the idea of ngram, right? Now we are using this bag of words. Here the bag of words are nothing but C used to analyze the text and document based on the word count. Okay, based on the word count. So model does not count for the words order in a document. Instead, it will take the frequency of the word present in it. So if you have the sentence about the bird, then its corresponding vector will be 1500200. What is that? It is a vector representation of the sentence about the bird. Okay. And similarly, you heard about the bird, then the vector representation will be 1110101. The bird is the word, so the vector representation will be 01012210. Okay, fine, 2210. Okay, is it clear properly how the bag of
Yes, sir.
words are
Yes.
getting constructed?
Yes. Yes.
Yes.
Counts the occurrences of the words.
Yeah, the number of occurrence of the word or the frequency of the words in the sentence will be, or in this example, it is given as a sentence, but you can consider this as a document. Okay, so
Yes. Yes.
particularly this matrix can be called as term document matrix. Okay, term document matrix. And usually when you convert this, the fox jumped over the lazy dog and fox are lazy, then you will get the representation as a sparse matrix. Okay, sparse matrix 072 means in the 0th row 7th column you are having the entry 2. 031 means 0th row 3rd column you are having the entry 1. Why it is actually represented as a sparse matrix? Do you know why it is represented as a sparse matrix? Because when you consider all the vocabulary or all the words in the vocabulary, English vocabulary, that will be present very rarely in each of the sentence, right? So most of the entries in that term document matrix will be 0. Okay, 0. So instead of keeping the matrix as such, you can simply keep it as a sparse matrix. Okay, so the sparse matrix is again converted into a set of vectors. Okay, dense vectors. Okay, fine. Now, what is the limitation of bag offers? See, the sky is blue and beautiful. The king is old and the queen is beautiful. Okay, love is beautiful. Love this beautiful blue sky. The beautiful queen and the old king. Okay, see what happened. What is the vector representation of the first sentence? We will be able to see what is the vector representation of first sentence. 1 1 1 1 0 0 0 0 1 1 0, right? Okay. Then the beautiful queen and the old king. Sorry, love this beautiful blue sky. What is the representation of that? 0 1 1 1 0 1 0 1, right? So if you look into the difference, the distance between these two vertices, the vector distance between these two sentences, what will happen? The difference will be very less, right? And about these two sentences, the king is old and the queen is beautiful. The beautiful king and the call on what happened? Both will have very similar vector representation if you consider bag of words, but that won't give you the better results. So that is why we are using this bag of words along with this diagrams or n-gram technique. See here, instead of simply creating the word, here what they have done is, see, they have took the beautiful and the next word, beautiful blue, the beautiful queen, blue, blue beautiful, blue sky. Likewise, we are having the n-grams and unigrams and we are filling the data. See, from this example itself, you can see that most of the observations will be 0, right? Okay. That is why it is stored as sparse. So this is the technique of bag of words. The next is term frequency inverse document frequency matrix. So in the previous example, as I said, can you tell me the vector representation, the idea of vector representation regarding the statement, I love ice creams. Okay, I love ice creams, but I hate lies. Okay, I hate lies. And you can think of the opposite. I love, okay, I love ice creams. I hate lies. But the second sentence is, I love hates, but I hate ice cream. What will be the vector representation of these two sentences in bag of words? Can you just think of it and tell me the answer? I love ice cream. I hate. I love ice cream. I hate lies. I love lies. I hate ice cream. What will be the vector representation? Will it be same or not? Will that vector representations same or not?
It must seem like sort of palindrome strings.
Yeah, they are actually having the same feature, right? Vector representation, as we are not counting any kind of repetitions and all. We are just taking the words in it, and we are not keeping the sequential information, right? Okay. So we have to make clear that the representation of bag of words are not good enough for representing a text as a feature. So as a remedy for that, we have created another, or we have introduced another method, which is called as term frequency inverse document frequency matrix. Term frequency inverse document frequency matrix. Okay. So with this, what you can actually get is each of the word will get a value. Okay. Each of the word will get a value depending upon its importance towards the document. Depending upon its importance towards that document, instead of assigning the simply assigning the frequency of each word in that document. Is it clear? Are you getting it? You will get more clarity on while I implement the program. Okay. So keep in mind inverse document, term document, inverse document frequency matrix, TD, TF-IDF. Okay, TF-IDF matrix. We can make use of TF-IDF matrix to find the importance of each word towards a particular document rather than equally distributing over the entire space. Okay. And word embeddings are again another technique within NLP we are widely using, that a technique that represents words as a number so that the computers can process them. Okay. So what we usually do is we represent each word. Okay. We represent each word as a sequence of numerical values. Okay. As a sequence of numerical values. Yes, a sequence of numerical values. And what is the peculiarity of those sequence and the values? If you consider two words which are synonyms, okay, then their vector representation will be close enough. If you find the distance between that two vectors, then the distance will be very, very less. Okay. So if you find the vectors of two different words in two different contexts, definitely they won't recognize. Sorry, like if you have two words which are having very opposite meaning, the vector distance between these two vectors representing those two words will be very high. That is the idea of word embedding, and word embedding can be created with the help of continuous bag of words, skip grams. They are all different techniques that we can depends for making the embeddings. Okay. So usually for the text classification, the sentiment analysis is a text classification. Do you know what is a classification task with respect to machine learning? What's the classification? What is regression? Exactly the difference. Hello, I'm audible.
Yes, sir. So classification is label the unlabeled data, and regression is a model. A regression is a clustering technique.
Okay, so there are some
Classification defines the object belongs to which category.
okay.
Defines predicts the next continuous value.
Okay, yeah, there are some misconceptions, I think. So I will
In
first,
classification,
yeah,
sir, in
yeah, yeah.
classification, the target variable is generally a qualitative. It may be a category or a class, but in regression, the target variable is quantity, like a continuous value.
Okay, yeah, yeah, exactly. That is the difference. So I can make it more clear with some example. Okay. So suppose we are considering a set of data which are having features and labels. Okay. And mostly, what is the purpose of machine learning? Machine learning is used to map a set of inputs into a particular output value, right? So if you're having the details of a student, whether the student will pass the exam or not, whether the student will pass the exam or not, then with the help of machine learning, we are finding the relationship between the features of a student to a particular decision whether the student will pass the exam or not, right? Okay. So for this, if you consider the data, the target will be two different values. What are they? The pass or fail, right? Pass or fail, right? So here the inputs are actually mapping into two buckets. Okay, two buckets. The first bucket is pass, or the second bucket is fail, right? So how many students you are taking for the data collection does not matter. Whatever it is, the output labels for all this 100 students or 10,000 students or 1 lakh students, whatever amount of students you have taken, the output variable is actually will be either pass or fail, right? Are you getting the idea?
Yes, yes.
Then the target can be considered as a discrete set of values. Okay, discrete set of values. Okay, it's a fixed set of discrete values. But when it comes to another problem, that is instead of finding out whether the student will pass the exam or not, if we are trying to find out the what will be the percentage mark a student will obtain for the next exam. What about the nature of the target? What about the
So
nature of the target?
it's continuous value, sir.
Yeah, they are all continuous values, right? So in the first case, we are mapping the inputs into a fixed set of discrete values. And in the second case, we are actually mapping the set of inputs into a real continuous value, right? Now, the first process is called as, or the first task is called as classification. And this is called as, the second one is called as regression. Okay. So if I ask you some scenarios, can you just tell me whether it is classification or regression? Uh, from the image of a person, predicting whether he's a male or female. What is that?
Classification.
Yeah, it is a perfectly classification example. From the image of a surveillance camera, you are predicting whether the person is wearing a helmet or not.
Again, it's classification, sir.
Again, it's a classification. From in the image of a person, you are trying to predict the age of a person.
Regression.
Yeah, perfectly. It is a regression because the target is a continuous value, right? From the video, surveillance video, you are trying to estimate the speed of a person, speed of a vehicle.
Again,
Regression,
it's a
sir, again.
regression.
Yeah, again,
Regression.
it is a regression, right? I hope you understood what is regression and what is classification, right? So what do you mean by text
Yes.
classification? By taking the input as a text, we need to map that text into a particular bucket, right? So according to the problem, that bucket can be anything, right? If you are doing a sentiment analysis on the text, the bucket can be the neutral, positive or negative, right? If you're trying to find the category of topic you are always reading, okay, again it is a classification, right? So this kind of mapping a text into a set of buckets are actually called as text classification. I hope you got the idea, right? Have you got the idea?
Yes,
Is it
sir.
clear? Is it clear?
Yes,
Yeah.
sir.
Now we can move to the demo of what all things we have discussed so far. Okay. Is the screen visible to you?
Yes, sir.
Yes,
Yes,
sir.
sir.
Visible.
Yeah.
Yes, sir.
Okay. So now we are going to discuss about text feature extraction. Okay. So for the text feature extraction, see, I'm using another package. So what are the packages so far we have used? Can you just name it? We have used two packages. What is the first one and what is the second one? Anyone have the idea?
NLTK, sir. And
The
NLTK.
packages. Yeah, one is NLTK and one more thing we have discussed.
Okay.
You remember that? Spacing.
Spacey.
Yeah, exactly. Spacing. Yeah. And this is the third package, which is called as text blob. Okay, text blob. So we have loaded the text blob and we are having a sentence here. See, using the text blob, I'm making this into diagrams. Okay. See what is the output you are getting. What are students? Mhm. So to get this, I need to install this thing, okay, download this thing. Okay. Now I'm just applying the engrams on 3. Someone's hello, someone's mic is on. Please mute it. Yes. Okay. Maybe because of the different versions in the Google Collab, there will be some kind of issues that are happening. Try to know if it is not actually official. Check this. Yeah. There we have another right. Yeah. So we got the n grams. See, this is a sentence. This is the first document. This document is the second document. So whatever data it is converted as this is this first the first document. Likewise, it is converted into trigrams. If you give the option 2 here, you can see it is converted into diagrams, right? So it's our choice whether we need to keep how many n grams for the further processing, right? So after that, the bag of words model, okay? So these are the corpus and these are the documents we have, okay? So to create bag of words in sklearn, there is a particular package which is called as count vectorizer, okay? So just create the input of count vectorizer, and when applying our input to count vectorizer, see, as I said, you will get a sparse matrix, okay? It is sparse matrix, and these are the columns we have considered, that is and document. First is one, second, and the third this. Okay. So since it is a dense matrix, we can convert that into array, and so that you can see this. See, this is a Word document matrix. Okay. Or using the count vectorizer, you have created the such a wonderful features. Okay. Right. So this will be the features. This is just for the creating a data frame out of the inputs. Okay. Now, after creating this, if you have a new sentence, that new sentence will get transformed into this vectorizer. With the help of vectorizer, give the text 2, then you will get the vector representation of 0, 0, 0, 0, 0, right? Because why it is actually not getting the answer? The previous corpus is not having such words like they love NLP but cannot learn in 2 months. Okay, so that is why this vector representation is getting a 0, 0, right? And this is another example. Food was not bad. I am not feeling bad. See, we have created the bag of words representation, right? Okay, is it clear? Is there any doubts? Is there any functions that make you confused?
So clear, sir.
Yeah, clear. Okay. Now, keep in mind in this type of count vectorizer, we will keep only the frequency of each entity or frequency of each token we have considered, right? And in the second case, this is a term frequency, inverse document frequency matrix, TF-IDF matrix, okay? So here, again, you are getting some representations, right? I love NLP. NLP is the future. I will learn the NLP. You can see the values representing love, NLP, the see. So for in the first document, you have the words love, NLP, the right. So we are getting the value 0.76, 0.45, 0.45. NLP is the future. Okay. NLP is the future. That is also getting represented as a matrix. Again, I will learn the NLP. Okay. Now, what is your thought? The word love is having a 0.76 value, and the word NLP is having 0.4 in the first sentence and 0.5 in the 0.35 in the second sentence. What is your observation?
In the first sentence, the values are different, and the below two sentences are having slightly
Yeah,
same values.
yeah. The inference you have to get from this is, see, the word love is very specific to the first sentence, right? So we can conclude that that word is contributing much towards the discrimination of that word. But the word NLP is present everywhere. So it is not a very specific word that gives the nature of that sentence, right? Are you getting the idea? Are you
Yes, sir.
getting the?
Yes.
Yeah.
Yes, yes.
So that is why the word NLP is having less importance. The is also having less importance. But we are getting love is having a high importance. Also is and future is having a high importance, because in other uh, sentences or in other documents, those words are not present. Okay, so those are actually important. Is that clear?
Yes, sir.
Yeah. So if I ask you, if I add feature NLP future, what will happen to this matrix? Whether the value of 1 will increase or the value of 2 will increase for the word future. What is the intention? If I add one more future here, what will happen? Can you guess what will happen to the value 0.608845? Will it increase or decrease?
Sir, why that future and this learn are having same number in different this one sentences?
Yeah, because in the first sentence, okay, the first sentence, the word love is present. In no other sentences it is present, right? So that is
Yeah.
a unique feature that can be considered to differentiate the first sentence from the other two.
Yeah.
So
But
it is
in the
having,
third sentence, learn will be the main this one.
yeah, in third sentences, the learn, and in the second sentence, the future is important, right? So they are
Okay.
having a near value 0.6 for the future and 0.6 for the learn, right?
Okay.
So
Okay.
what I'm asking is, if I include future in the first sentence, what will happen to the value feature here? Will it reduce or get increase?
It reduce, sir.
It will
It will
reduce.
get, yeah, we can see that it will get reduced and the value is actually getting distributed over two sentences. Are you getting the idea?
Yes, sir.
Yes,
So
sir.
the
Yes.
TF-ID of matrix is giving the vectors by considering the importance of each words towards a document, right? Okay.
Yes, sir.
Yeah. So this is okay. So these are the things and the word embedding. Okay. For the word embedding, I'm just using another package which is called as GenSim. Okay. We are importing all the required things. We are splitting the text. We have the text X as petrol cars are cheaper than the diesel cars. Diesel is cheaper than petrol. Petrol cars are cheaper than diesel cars and the diesel cheaper petrol. Okay. So see what we have done is we have taken, okay, we have taken the sentence, okay, in X and given to the word to X. And here we are telling that the vector size is 2. The vector size is 2. That is, when we are converting the sentence into a vector, that it should be 2. The window for considering it is 4. So after that, we got the weight to vec model for the sentence X. Okay. Okay. So you got the vectors. In the newer version, the function is actually getting changed. So these are the keys, and with this we can actually convert our data into vectors. See, right? So here the vector size is 100. So each word will be converted into a 100 length vector, and the other parameters are also important. So from this data, we have created a vector representation for all the data. So I can do this experiment by keeping the window size as 5. So what will happen here? Each of the sentence will get converted into a vector size of 5. Okay. So I can show you one more example. See, so let me connect here. Okay, yeah. So I'm installing Gensim here. Yeah, we have the data and we are splitting it. So with this data, we can actually create a weight-to-weight model. That is what we are creating now. Weight-to-weight model, you have to give the vocabulary and you have to give the vector size. So after that, see, every input is actually mapped into a particular index. Okay, NLP, the I and all. Right? Then we are converting that to the corresponding vectors. So we can see that each of the word NLP, the I, learn, will, future, is, love, will get converted into a two-dimensional vector. And if you plot that two-dimensional vector, you can see how it is getting distributed. Okay. Are you clear? Is it clear for you?
Yes, sir.
Yeah. So in a general fashion, what we are doing is we will convert this vectors into a large dimensional. Sorry, convert this words or tokens into a large dimensional vector so that we can accommodate more number of vocabularies to our office. Okay, right? Now we are going to discuss how we can implement the entire pipeline of a text classification process. Okay. So before that, can someone conclude or can someone make a recap on what all things we have discussed so far? Anyone? The points we have discussed so far.
We studied the basics of NLP.
Yeah. Then, are you speaking? I think there's no voice.
The lemmatization, word block,
Yeah.
and vectorization.
Okay. Vectorization. Yes. So finally, we have got all the prerequisites requisites for our classification implementation. Okay. Upload notebook.
So can you share this Python code because we are not able to cope up with all
Yes,
the
yes.
code?
Yeah, I will share it. Now we are going to do experiments on this text classification and the sentiment analysis. Okay. So here there is a sample code and I'm loading in data. Or in the data. Upload your data here. From here, I'm just loading dataset.csv, which is a data set which is having the customer's review on a movie, okay, or the audience review on a movie. See, these are the reviews, okay. These are the reviews, and according to its goodness, we have mapped it as 1, and some others are actually zeros. Okay, so we are actually going to create a machine learning model, okay, to predict whether a given review will be positive or negative. Okay, positive or not. Okay, so I have loaded the data. So the first part, import pandas as PD data equal to PD dot read CSV data set dot CSV, and we are just printing the head. So we are loading the data, and we are just printing the first 5 rows by calling the function data dot head. Okay. Right. In the next block, we are just simply printing the data dot info. That will show us if there are any null values in the thing and all. Right. Now, to do a simple analysis from the data, there are 2 columns, category and message. The category dot value count, and simply printing the sentiment count. Okay. So it is for the positive reviews and negative reviews. We are having around 700 or 800, nearer to 800 reviews. Okay. Now the things are here. First, we have to create a regular expression for the tokenization process. Okay. And we have to create a count vectorizer. Count vectorizer is in the form of a scalar. Like here, we have to specify the lower case. Stop words need to be considered from English. We have to keep the n-grams. The tokenizer should be defined as this. Okay. Then on applying CV dot fit transform of data of message, every message will get transformed into
Sir, excuse me.
Yeah.
Sir, actually, what you are explaining is not in the screen. I hope the screen is earlier screen it shows.
Not showing properly.
But
Yes,
I
sir.
can. But
It
I
was
think no problem.
it was visible, sir.
Is it visible now?
Yeah,
Properly?
visible.
Yeah.
Don't have an issue.
Visible
Okay.
clearly, sir.
Yes. Yes.
So
It
now
might
we
be
are might be a delay in your so receiving end. So we are creating a count vectorizer. We are specifying all the things need to be converted into lowercase. You have to consider the English vocabulary for stop words. Just consider the n-grams as 1 and tokenize using the tokenizer specified here. So this is a shortcut where we can do all the process as a single pipeline. Otherwise, we can do these things one by one as we did in the previous example. After that, if you are fitting the data of message, then you will get the vectors directly. See, you will get the vectors directly. Okay. So this is in the dense form. Okay, dense form. Maybe you can convert that into matrix to query. Maybe you can just try it out. This will be the array representation in between. Then you can even take the shape of this. So the shape is 1499, comma 4335. That is, there are 1499 observations and 400 4335 words. Okay, that is why we are getting the output like that. After that, what we are doing is we are splitting the data into training and testing. Okay, splitting the data into training and testing. Then we are applying our data, X train and Y train. Okay, X train and Y train on the support vector classification model with a linear kernel and C value 0.8. And we are predicting the result with X test. And on calculating the predicted value as well as the Y value, you can see the accuracy is around 0.95. You can also see the classification report. So from here, it is actually having 96 accuracy. And this is the confusion matrix. Okay, this is the confusion matrix. See, and from the confusion matrix itself, we can evidently see that only 2 samples are getting misclassified and 18 samples are getting misclassified from class B. So in total, there will be how many observations? 218 plus 2, 220 plus 230. Okay, 220 and 230. Around 450 observations are there. Okay. Then this is the last part on giving it movie super. You can transform that same input to the vector. And the vector is getting predicted as 0. Okay, fine. So this is the entire pipeline of a NLP classification model. Or if here the labels are given according to the according to the review of a particular game, right? It can be anything. This can be anything, like it can be a sentiments, it can be the type of document, whatever it is. If you have a data like this, you can do the same thing in a very faster way. That is the text classification. Because in the case of images, for particular tasks, the features we need to extract from each of the image will be different, right? But in the case of text, that is not the case, because we can have the bag of words or TF-IDF matrix or whatever features it is. Okay, whatever problem it is, we can use the same set of features for all the problems. Okay, have you got it? Any clarifications needed in this pipeline? Is there any doubts or any clarifications needed? No? Can we move to the next part?
Yes, sir.
Yeah. So this is how the machine learning is actually utilized for the NLP, and there is another trend is actually happening as the machine learning suffers from extracting good features for the process of classification of, or regression or whatever it is. We are introducing deep learning as a solution for that, right? Deep learning. And in the case of deep learning, instead of explicitly extract the features, the network itself is capable of extracting the features. Okay, network itself is capable of extracting the features. Okay, and there are a variety of deep neural architectures available, convolutional neural network, recurrent neural networks, like that, right? And particularly in the case of recurrent neural networks, okay, they are neural network model which are capable of handling sequential data or data with temporal dynamics. Okay, data with temporal dynamics. See, because if you look into these two sentences, the basic unit of information in both the sentences are same, right? I love India and hate terrorism, and I love terrorism and hate India. Both the elements, unit information elements are same, but overall the context is not same. They are two different contexts, right? So how you can tackle such kind of data with temporal dynamics? So here the importance is that each word need to be aligned with a particular timestamp. Okay, then you can make use of learning that. Okay, then we have to tackle the temporal dependency between each of these tokens with the help of neural networks. So such applications are widely implemented with the help of a recurrent neural network, a special kind of neural network. Okay. So what is a recurrent neural network? A recurrent neural networks are class of neural network that are helpful in modeling sequential data derived from feed-forward networks. RNN exhibit similar behavior to how human brain functions. Okay. So when to use recurrence or why to use recurrence? Whenever the temporal dynamics of the data is important, we have to use the recurrence. Okay, we have to use recurrence neural network. Okay. So recurrent neural networks are very similar to feed-forward neural networks, but the difference is that the input from one step will be given as an output to the next step. Input one step was given as an output to the next step. Okay. So sorry, there's a change. That is, the output from the one neuron will be taken as an input to the next data point. Okay, so with this, what we are actually trying to induce is that, see, if this is the node, a single node in a recurrent neural network, on getting the data or vector for the word what, the neuron will learn what is what. Okay, then on getting the next tokens vector, it will have the memory of both what as well as time, because it will preserve what is actually outputted from the neuron, right? So likewise, at what time is it? After completing the entire sentence, the neuron will have the information regarding all the previous data. With this, the neuron is itself is capable of handling the temporal dynamics of the data. Okay, is that clear?
Yes, sir.
Yeah.
Sir, sir,
Yeah.
can I ask you a question?
Yes, sure.
Sir, please tell me what is the exact difference between ANN, CNN, RNN?
Yeah, I will tell you.
So what's
So
the main point?
yeah, ANNs are simply multi-layer perceptrons. Okay, they won't do any kind of magic. Okay,
Okay.
ANNs will simply take whatever features we are giving as an input in multiple layers. It will extract very useful informations, and finally it will create some kind of classification or regression, right?
Yes.
And in ANN or simply a multi-layer perceptron, we have to explicitly give the features to it. Okay. But CNN is something which is capable of handling spatial data. Okay, I can show you what is it. What is it? Are you able to see my screen?
Yes, sir.
Yeah. So both these are actually artificial neural networks. The one is like our nervous system, like or our
Biological neuron.
yeah, biological neuron. This can be the receptors. This can be a brain. This can be the reaction mechanism we have, right? So by taking the input, the brain will do some computations. According to that, we will react, right? Okay.
Yes.
And this can be extended to a deep neural network by adding more number of hidden layers. So by adding more number of hidden layers, what we are actually trying to do is the thinking process or the computation happening on the brain is in a more deeper way, right?
Yes.
So these simple structures are capable of doing some computations with the inputs arriving at this blue circles and make some outputs here. Okay. So maybe the correlation between these inputs, how they are actually making a pattern, these things are actually calculated within this. Okay. And when it comes to when it comes to sorry, it is not. Yeah. See, can you see this? See, this is what we are calling as a spatial data. Okay. So an image can be considered as a spatial data. See here, we have all the pixel informations, 784 pixel informations in one set. But are you getting any kind of meaning from this? Even though we are having all pieces of information, is it possible to get some information from this particular data?
No, sir.
No.
No.
No, sir.
But if this data is arranged in a row column fashion, see, row column fashion, are you getting the information then?
Yes, sir.
Such kind of data is actually called as spatial data.
Mhm.
Okay. So
Yes.
this spatial data, can be handled with convolutional neural network. So in convolutional neural network, we have a final part as our multi-layer perceptron or a simple ANN, but there is a dedicated part here. Are you able to see this? This is what we are calling as convolutional layers. Okay, so convolutional layers are responsible for extracting the spatial dynamics from the inputs which are spatially distributed. Okay, so for this purpose, for the purpose of applying it into this part, we need not to explicitly say what all features we need to take in from this image. Then this part of the network itself is capable of extracting very good and relevant features from the input. Are you getting it?
Yes, sir.
So that is what calling as the spatial dynamics. And the spatial dynamics is captured using the convolutional operations in the convolutional neural network. Okay.
Yes, sir.
Okay. So in simple artificial neural network, that is not possible. We have to
Yes.
give we have to do all the inputs at this point and do some kind of classification or regression. Okay.
That is union work for image only.
Yeah. For images or with data which is having spatial importance can be handled with CNN. Sometimes the
It is raw
signals.
matrix.
You can consider it as a matrix. Maybe sometime the signals are converted into frequency domain, right? The time
Yes, sir.
dependent domains are converted into frequency domain. Then it can be having a spatial structure. Then that can be handled with a CNN. Okay.
Sir.
And coming back to the RNN, see, RNNs are particularly dedicated to handle data with temporal dynamics, not the spatial dynamics, with the temporal dynamics. So how it is getting work? See, there is a backward loop in the neuron. So on getting what, it will keep the information of what. But in a usual neural network, when we get the information regarding time, the information regarding the what will get forgot. But in recurrent neural network, as we are having the recurrent connection, the information regarding the what will also be preserved on getting the next input. Okay. Similarly, it is capable of tracking the information regarding a sequence of inputs. Right? So it will keep the temporal dynamics. It will keep the temporal dynamics within the data. And with that temporal dynamics, we can make use of the decision making and all. Are you getting it?
Yes, sir. Yes, sir.
Yeah. So this is the actual thing. See, we have
Yes,
the
sir.
input. The input is getting thing concatenated with the memory from the previous state. That is actually getting processed and we are creating the memory of the current state. So what you can assume is within this memory, you will have the information regarding this input as well as this input. Clear?
Yes, sir.
Yeah. So that will keep the temporal dynamics, and the temporal dynamics is actually implemented with a particular kind of backpropagation called backpropagation through time. And see, there are different versions of recurrent neural networks. The simple recurrent neural networks are there, but one of the major drawback is, see, what is happening to the information we are keeping at the end. Are you able to see that information perfectly on the end? This black color.
No.
So it is actually getting degraded, right? So if the length of the sequence is actually getting increased, what will happen? The information regarding this first inputs will get vanished, right? That is what we are calling as vanishing gradient problem. And this vanishing gradient problem will cause a short-term memory, right? It can't preserve a long-term relationship. It will make a short-term memory, right? So to
Right.
expand that short-term memory into a long short-term memory, we are using a modified version of recurrent neural network, which itself is called as short-term memory models. Okay, so what is the idea behind this long short-term memory is, instead of keeping all information getting on the neuron, we will keep track of the information which is very relevant to the decision making with the help of long short-term memory. And the long short-term memory is having some more complex structure, and that is again rectified using the gated recurrent units. Okay, that is another type of RNN, which which is having the same features of LSTM, but it is not much complex than the LSTM. So with this architectures, we can actually handle the textual data in a very efficient way by keeping the temporal dynamics. Okay, so similar to this experiment, I will show you one more experiment, which is again a text classification based on this recurrent neural networks. Okay, so I have loaded the data. Sorry. Sentiment analysis. Okay. So for sentiment analysis, I'm just loading the data, movie reviews. Okay. So the data is loaded. So the data is nothing but we have the review of different movies and its corresponding sentiments. So we are building a recurrent neural network model to classify this movie review into positive or negative. Okay. So we have loaded the data with the help of pandas. You can see the data, the reviews and the sentiments are there. Now we'll take the column the sentiments in a variable called summary, and we will take that values, the sentiment values into labels. Okay. So if you print summary, you can see all the sentences. If you print the labels, you can see all the label outputs. Okay. After that, what we are doing is, see, we are doing a tokenization process. For that, we are keeping maximum of 500 tokens, okay, and applying on the summary, right? Then we will create a vocabulary by taking all the distinct words from the tokens we have currently generated. Then we will convert that each of the sentence to a sequence of values. Okay, sequence of values. So that is actually implemented at this point. Okay, and the patch sequence is done for as the length of the sentences are different for different reviews, right? So, but for making it is acceptable by a neural network, we have to make all the sentences into a fixed length. So the fixed length is 200. So if the sequence is not enough, then it will get paired with zeros. Okay. So you can see the output. See, after the tokenization, you can see that each word in the entire document is each word in the entire document is mapped to a numerical value, right? So by taking that numerical value, what will happen? You can sentence, you can convert a sentence into a sequence of numerical values, right? That sequence of numerical values again will get padded because the length of the sequence should be 200, right? So the rest of the values will get appended with zeros. Okay. So likewise, all the inputs are now of length 200. Okay. Now of length 200. Now we are creating an embedding layer. Then with that embedding layer, we are going into an LSTM model. LSTM model will have 500 neurons. Okay. Then just I have created a model. So I have how many layers? Embedding layer, a spatial dropout layer, an LSTM layer, a dropout layer, a dense layer. Okay. So with that layers, you can get the behavior of your model. And we are using the binary cross entropy here, the ADAM optimization as a optimization technique. Then finally, what we are doing is the padded sequence and the labels are together given into the model training. So on training, you can see that it is getting learned. See, the accuracy is gradually getting improved. Please, someone's audio is actually on. Please mute yourself. See, the accuracy is increasing from 51 to 65 to 69. We can wait for some time. Training process is actually happening. And trying it with other models like LSTM, you can simply change it as simple RNN, or you can simply change it as GRU. That is not a big deal. You can change that with a single change in a single line of code. That's about to finish. 4 epochs are over. Yeah. Finally, the last epoch, the accuracy is now attained to around 86%. Okay. Okay. So the accuracy is now 86%. So this is too sad is a new comment, and I'm again converting it into sequence, padding it and converting that and applying onto the model to predict. So it is labeled as 1, that is a positive prediction, right? So these are the two different versions of how text can be classified with machine learning techniques. The first one is the naive NLP approaches plus traditional machine learning algorithms, and the second one is the LSTM, the deep learning approaches with LSTM, GRU and all. And now the trend is also changed. That is, the recurrence is actually overridden with the attention mechanism. Now the current state of our techniques for handling text is transformers. Okay, transformer architecture. And as a part of transformer, there are BERT, GPT and all. And now the area of NLP is actually boomed with this invention of the transformers. Okay, so that's all for today's presentation. I think it's 8:54. We can have a question answer session if you want to ask any questions regarding NLP, deep learning, machine learning, and all. Okay, Hope you had a fruitful session. I will share all the codes and PPT with the organizers. I think that will reach to you very soon.
Sir, this while listening your lesson class, I have switched on the caption. In the caption is coming. This is based on the NLP, natural language processing.
Yes, yes.
And why there is some mistakes, like, when you talk audio, it says odd, something that words are, different what you are talking. Why, what may be the reason?
Yeah, that might be possibly this application is from the foreign countries, right?
Yeah.
And the model may be trained with English accents, which is good from US or UK people. So our pronunciation is having some kind of defects. That is why it is getting mistaken.
Okay, thank you.
Sir, I have a question. For Python, we have like for NLP, we have mainly focused on English. Are there any other libraries for other international languages or like
Yeah,
other than
even for Indic languages itself, the Bharat AI, the Savam, those companies are actually uh, creating APIs for Indic languages. If you look into, have you heard about the repository Hugging Face? Do you know what is it?
No, sir, no, never heard.
Yeah, Hugging Face
Yes,
is a
sir.
model. Yeah, Hugging Face is a model. See, here you can have different models that can be used for Indic languages. See, Indic parser, Indic Bart, a lot of models are available for Telugu. This is actually taken care by AI for Bharat initiative. It is an initiative by IIT Madras, I think. A lot of remarkable works are actually getting uh, pushed by this companies. They are all implemented in Python itself.
As far as English is concerned, sir, the accent and the pronunciation is mostly depend on the mother tongue of the user.
Yes, exactly.
So it will be. I don't think it will be like if we consider the speech to
Common
text.
people. Yes, yes, yes.
So this
But some of the models are there, uh, which is trained on the Indian the Indian accent.
yes.
Any other doubts?
So can you please explain what you mean by transfer learning?
Ma'am, can you tell me again?
And sir, can you please explain what actually is this transfer learning? Can you use the
What? Okay, what is transfer learning? That is the question, right?
yes.
Yes. Okay. So, if as far as concerned about a neural network, okay, suppose you have a neural network, right? And a neural network is trained to classify a dog and cat, okay? So, how the learning process is happening at the beginning of the neural network training, it is not having any kind of knowledge to classify dog and cat, right? By consuming the data, by looking into the patterns of cat and dogs, finally, after experiencing a lot of amount of data, the neural network model will be able to identify whether the given object, whether the given image is a cat or dog, right?
Yes, sir.
So that model is particularly trained for a particular task or a given data, right? And the initial setup for this training is completely random, right? So as
Yeah.
the problem is getting more complex, the pattern need to be identified will be more complex, and it will take more and more time to converge into a proper model. Are you getting my point?
Yes, sir.
Yes. So instead of starting from that random state, okay, random set of knowledge, if you have some knowledge, you have, okay, if you have some knowledge, and if you start training your neural network from that point, what will be the advantage? It will be more easy
Okay.
to it will be more easy to learn by that model.
Hello.
And hello, right, it will be more easy to learn by that model, and the convergence will be in very less time, right?
Yes.
So the idea of transfer learning is that the model which is trained for one problem can be used to train, or can be used to train on other problems which are very similar to it. So we are transferring the knowledge from one problem to another problem. That makes the learning process much easier and faster. Like if you have a model for classifying the brain tumor, okay, brain tumor, then you can make use of that of model for training a model which is for lung cancer or not, right? Because both the data's modality will be same, right? Maybe it will be an MRI image or a CT image, right? So the peculiarity learned by that model from this data for brain tumor can be utilized for training a model which is to detect the lung cancer. Are you getting it?
Yes. Yes.
Yeah. That is what the idea of a layman perspective idea of transfer learning.
Yes. So for whether a vision transformer can be used for some text classification or something, or it can be used only for classifying images only.
Yeah, vision transformers are particularly used for images. There is no need to use vision transformers for text, because the transformer architecture itself is dedicatedly created for text. We are just tweak that transformer architecture, which is in a way to use this vision transformers. So for textile data, you need not to go for vision transformers. You can simply use the transformer itself or as a BERT or a GPT itself.
Okay, thank you, sir.
Hello, excuse me, sir.
Yeah.
Sir, my previous project was speech emotion recognition. I
Okay.
used RavDas dataset for it. That
Okay.
was American English. That was in American English audio files. Now I
Okay.
am thinking to do the same project in local language, like as I am North Indian from Haryana, the
Okay.
Haryanvi language or Hindi language.
Okay.
Where can I find the public data set for the regional language?
It is actually very difficult to get such kind of data sets because most of the data sets are owned by different project people. So I don't think there is a public repository for all this currently. Maybe in the coming days, people will publish it.
Okay, sir. So, sir, in Hindi also there will be no data set available.
There will be some sophisticated data set, but it won't be reliable actually.
Okay,
Much
fine,
for
sir.
the
Thank
real
you.
certification. Yeah.
Yeah, good evening. I have one
Hello.
question.
Yeah.
Yeah, can you give some information about tokenization or tokens in Indian languages? Because when it comes to English language,
Yeah.
we have this word tokens or subword tokens, those things. Because
Yeah.
entering a character is one stroke, but it's not with Indian languages. In
Yeah.
Indian languages, if you want to enter one complete character, it may require more than one stroke, one keystroke.
Yes. Yes. Exactly.
So, I mean, how do we do tokenization if you're
Yeah,
using any of the deep learning models?
ma'am. Actually, that projects are itself is on the go.
Okay.
As I said, the Bharat AI, the server computing, those people are actually building such kind of language tools for
Uh-huh.
specifically on Indian languages. So if you
Okay.
go to Hugging Face,
Yeah.
you can find the tokenizer for Indian languages. I think some of them are already available with Hugging Face models.
Okay. 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 Thank you. I'll look into it.
Yeah.
Thank you.
Shruti,
Hello.
hello. Any questions?
Hello.
Yeah, ma'am. Hello.
Sir, if I want to work with multilingual data set,
Okay.
then which algorithm for deep learning would be preferable?
The current for the purpose of what? Is it for classification or generation?
Actually, I am working on sentiment analysis. So, like taking the comments from the social media to find out the sentiments.
Yeah, okay. The mostly you can make use of BERT and you
Okay.
need to fine tune it. That will be the solution.
Fine
It
tuning
is,
the BERT model.
yeah,
Okay. And as one person told that getting the data set in a local language is difficult.
yeah, it is too difficult.
So, yeah, so multilingual will be preferable for that if I try to get low resource data set.
You can make use of a unique representation of multilingual text. Then you can
Sorry,
apply
sir.
for BERT.
Sorry,
You
sir.
can have
Uh,
some kind of vectorization models
okay.
that will handle multilingual data, okay, multilingual
Okay.
text. Then that
Okay.
vectors can be again used for the BERT. That will be
Okay.
an ideal choice. So that
Okay.
making such a vector representation itself a big work.
Okay. Okay, sir. Okay. Thank you, sir.
Shruti,
Thank you so much, Dr. Shailesh Shivan, for such an insightful and thought provoking session. Your session was truly insightful and inspiring. In the first session on overview of natural language processing, he gave us an introduction to this foundational area of artificial intelligence. He taught us how NLP acts as a bridge that allows machines to understand, interpret, and even generate human language, whether it's through processing voice commands, translating languages, or analyzing text. He have unpacked the core principles of NLP, explaining how it underpins many technology we use daily, from virtual assistants to automated chatbots. So, your second session on customer review analysis using machine learning and NLP techniques focused on practical applications. By combining theory with real world examples, this session showcased how AI empowers business to make smarter data driven decisions. You have not only deepened our understanding of these complex subjects, but also inspired us with practical applications and innovative insights. Your ability to simplify intricate concepts, coupled with your immense experience in both academia and industry, has left a lasting impression on all of us. The real world examples and practical demonstrations you shared have enriched our learning experience and opened new avenues for exploration in the field of AI and machine learning. Once again, thank you, sir, for sharing your expertise and experiences with us. It has truly been a privilege to have you as a speaker for this session. Now, I invite Professor Sarita MS.
Thank you so much, sir, for your insightful session on NLP and machine learning. Your expertise and engaging presentation have greatly enhanced our understanding of these advanced topics. As a token of appreciation, we would like to present you with a virtual memento. This is a small way to say thank you for your time.
Thank you.
Your feedback is very important to us. We will share a feedback form in the chat and in the WhatsApp group. Please take a few minutes to fill it out as it is essential for marking your attendance. Please note that the participation ID has been published in the WhatsApp group. With that, we come to the end of today's session. I extend my heartfelt thanks to our esteemed speaker, Dr. Shailesh Shivan, for his enlightening session. A special thank you to our coordinator and co-coordinator for the dedicated efforts in organizing this event and ensuring its smooth execution. A special thank you also goes to our faculty chair, Ms. Jebin Matthew and Ms. Sarita MS, for their guidance and support, and to all the participants for your active involvement. Thank you once again to everyone for being part of this enriching experience. We look forward to seeing you all again at tomorrow's session. Wishing you a pleasant evening and a good night.
Thank you. Good night.
Thank you very much, sir. It was a very nice session, sir. Thank you.
Thank you, sir. Thank you very much.